Inventory showed 0 after the first few seconds, but customers got confirmations. 2 concurrent requests read the same row before either wrote. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover design an e-commerce platform. An e-commerce platform is a set of loosely coupled services. Each service owns its domain: catalog for product metadata, cart for sessions, checkout orchestrator for the purchase flow, inventory for stock, payment for transactions, and order for completed purchases. Separating these by access pattern is critical. The biggest mistake is bundling inventory with catalog. Catalog is read-heavy and can tolerate eventual consistency. Inventory is write-heavy and must never oversell. Keep them separate from day one. Product search must return in under 200 ms. Use Elasticsearch with change data capture from the product database. Cache product detail pages aggressively. Avoid deep pagination with search after. Here's a sample Elasticsearch mapping for product search. Notice we use keyword for categoryid and stock status, and text with analyzers for name and description. This enables fast full-text search and faceted aggregation. The checkout orchestrator runs a mini Saga. Validate cart, reserve inventory atomically, charge payment with idempotency key, and create order. If payment fails, release inventory reservation. This avoids distributed transactions. This Java code shows the checkout Saga. Note the idempotency key generated from userid and cartid. If inventory reservation fails, we return failure. If payment fails, we release the reservation. The order is created in an Outbox table for durability. Payment is the most critical subsystem. Use idempotency keys stored in a table with unique constraint. Retry with exponential backoff and jitter. Implement a circuit breaker to avoid cascading failures when the gateway is slow. This retry logic uses exponential backoff with jitter. On timeout, it retries up to 3 times. If all fail, it pushes to a dead letter queue for manual review. The idempotency key ensures no double charge on retry. Scale in stages. Start with a monolith and read replicas. As traffic grows, break out catalog and inventory services, add Elasticsearch, and use a message queue. For flash sales, over-provision inventory database capacity and use a Redis gate. Never use 2-tier architecture. It exposes raw DB queries. 3-tier is the baseline: presentation, application, and data tiers. Each tier must be independently deployable and scalable. This Python function maps traffic to architecture. Under 1K visitors, a monolith is fine. Up to 100K, add red replicas. Beyond that, micro frontends and partition services are necessary. Components that share a database are not independent. Inventory updates should publish events to Kafka, which the search service consumes to update its index asynchronously. Here, inventory update emits a Kafka event. The search service consumes it and updates its index asynchronously. This decouples the services and prevents cascading failures. Domain knowledge separates a working system from one that collapses. For example, inventory has different states during checkout V's restocking. Always enforce business rules like atomic decrement. This code enforces the domain rule: never sell more than physical stock. It checks available quantity before reserving. Without this, overselling is inevitable. Strategic DDD partitions the platform into bounded contexts. Each context owns its models and language. They communicate through events, preventing God classes and enabling independent deployability. The order context publishes an order-placed event. Other services subscribe to this event. This decouples the order service from downstream consumers. Tactical patterns enforce consistency within a bounded context. An order aggregate includes cart item entities and an address value object. The repository persists the entire aggregate atomically. The order aggregate root ensures invariance. The repository saves the entire aggregate atomically. Never load partial aggregates; it leaks business logic to services. This is the same issue we highlighted at the start. Here's exactly why that happened. 2 requests read the inventory row simultaneously, both see quantity 1. then both decrement. The second decrement oversells because the first hadn't committed yet. This is a classic read-modify-write race. The fix is to use an atomic decrement. Update inventory set quantity equals quantity 1 where producted and quantity 0, then check affected rows. If 0, reject. Also use a Redis atomic counter as a fast gate before hitting the database. This is the exact pattern that caused the incident. 2 concurrent selects read the same value, then both update. The fix is to combine the read and write into a single atomic update. Wildcard queries in Elasticsearch scan all terms, causing severe slowdowns. Use match phrase prefix with index prefixes mapping instead for up to 10x faster partial matching. Without an idempotency key, a network timeout leads to a retry that charges the customer again. Always generate a deterministic key per order attempt and send it to the gateway. The article mentions using Redis atomic decrement, but doesn't show the Lua script pattern. This snippet demonstrates a safe atomic decrement that returns the new stock count and prevents overselling in a single atomic operation. The article mentions the Outbox pattern, but doesn't specify that the Outbox table must be in the same database as the order service to ensure transactional consistency. A common mistake is using a separate database for the Outbox, which defeats the purpose. The article discusses circuit breakers for payment, but not for inventory. During a flash sale, if the inventory database becomes slow, a circuit breaker on inventory calls prevents cascading failures by failing fast and returning a friendly error instead of blocking checkout threads. When debugging flash sale issues, first check cache hit ratio, then monitor database connections. Use Redis CLI to verify the atomic counter. These commands pinpoint bottlenecks in seconds. Let's run through some common interview questions. How to prevent overselling in checkout? Use atomic update with where quantity and check affected rows. How to handle payment gateway timeout? Use idempotency keys, retry with exponential backoff, and circuit breaker. Single DB versus database per service. Single DB simpler but couples services. Per service scales independently but requires eventual consistency. And a few frequently asked questions. What causes overselling? Race condition in select then update inventory. How to ensure order durability. Use Outbox pattern. Write order event in same transaction, worker publishes to queue. Can inventory be cached? Cache as fast gate with Redis but reconcile with DB frequently. Never cache for checkout decisions. To recap, separate services by access pattern. Use atomic inventory decrement. Always use idempotency keys for payments. Scale in stages and never share a database between catalog and inventory. Ready to go deeper? Up next, design a content moderation system, then design a web crawler, then design Google Docs. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.